Hi, this is Maggie. In this video we're going to talk about falling. If not with some style, then at least with some realism. Here is a program I have written from our template called falling.py. In it, I've programmed our robot to drop from the top of the screen to the bottom at a constant speed of 5 pixels per second when the user clicks the mouse. And if I run it and click, it doesn't look bad, but it doesn't look like the robot is falling. Why is that? Well, there's no acceleration. On Earth, if something falls, the gravity of the Earth causes it to accelerate as it falls, so that it falls faster and faster the longer it's been falling. If we want to program more realistic looking falling, then we will need to use a projectile equation that calculates the effect of gravity on the y-coordinate of the robot as it falls over time. In other words, instead of adding a constant amount to y each time through the loop, we will need to add an increasing amount each time through the loop. For now, because we're working on falling straight down, we don't need to worry about the x-coordinate, which will remain the same as the robot falls. Falling can be thought of as a special case of projectile motion, in which there is no x-component of velocity, so no movement in the x direction. And the initial velocity in the y direction is 0. So if we take the projectile motion equations that are shown in the text, x is always x initial because the x component of velocity is 0. So this second term is 0. The robot moves in a straight line down. And y becomes the initial y coordinate minus 1/2 gravity times squared. We lose this middle term in the y equation because there is no initial y velocity. The object starts at a velocity of 0, and it's entirely gravity that is causing it to move. These equations were written for a coordinate system in which y increases as we move up. So we must adjust the equation for our inverted axis to y equals y initial plus 1/2 gravity times squared. Let's take a look at our program and have the robot fall with increasing speed according to gravity rather than move down the screen at a continuous rate. For this program, I have a variable called robot dy, which I set to 5. This is being added to the robot's y coordinate each time through the game loop. What I'll need to do instead is calculate how far the robot will have fallen according to how much time has elapsed since he started falling, and add that to the robot's initial location. So at the top, I'll change robot dy to robot initial y, and I'll also annotate and initialize a variable for time. Now, down in the game loop, once the user clicks, the Boolean falling is set to true. So if the robot is falling, I'll calculate robot y equal to robot initial y plus the gravity component of our projectile equation, 0.5 times gravity times time squared. So there are two parts of that equation I haven't worked out. One is gravity and the other is time. Each time through the game loop, 1/30 of a second elapses. So I can model the actual time that elapses by adding 1/30th to the time variable each time through the loop if the robot is falling. For gravity, the constant that we use for gravity on Earth is 9.8 meters per second squared. What I want to use for a gravity constant in the program is something that makes the motion appear correct. I'll start with a value for gravity that approximates gravity on Earth using the scale of the robot. If my robot is 1 meter tall, then my scale is 76:1 because the image is 76 pixels tall. Using that value, if I multiply 76 pixels by 9.8 meters, I get 744.8 pixels, which I might round to 745. If my robot is closer to human size at 2 meters tall, then my scale is 38:1, and my acceleration constant would be closer to 372. So I can define that constant at the top and use it in my equation and experiment with the constant until the motion looks right. Let's run the program. I think 745 didn't look too bad for this program, but I don't have a lot of experience of watching things fall. I might look for some videos to guide me. Now, I didn't like the robot dropping off the bottom of the screen, since there's a sidewalk or a road or something down there, so I enhanced the program to include a hovering state, and I made another robot image with a rocket from 2 images from public domain vectors, which is where the background is from as well. I check if the robot has started to sink below the bottom of the screen, and if it has, I set the falling flag to false and a hovering flag to true and change the image to the rocket robot. When it's hovering, I alternate between moving up and moving down a tiny bit by keeping a counter and hovering up for a second and then hovering down for a second, alternating. I just thought we should do something at the bottom of the screen and I didn't want to smash the robot. I called this version fallinghovering.py. So that is a program with some falling motion that is a bit more realistic. I recommend you take the template and drop an object according to the falling distance formula. Try something other than the robot and calculate a scale that allows you to determine a starting point for your gravity constant. When you can program some falling objects, you are ready to move on.